Welcome to a new lesson. In this lesson we'll be discussing angle properties and polygons. Now polygon is a shape that is closed and is composed of at least three sides and three angles. A convex polygon is a polygon in which each interior angle measures less than 180 degrees. For example, all of these angles right here, they're called interior angles, and all of them are less than 180 degrees. That's what we're going to be referring to in this lesson, convex polygon. There are other polygons, and this polygon right here, or at least this angle, this interior angle, is greater than 180 degrees. We're not going to be referring to this type of polygon in this lesson. Let's take a look at our first example. Prove that the sum of the measures of the interior angles of any n side of convex polygon can be expressed as 180 degrees times n minus 2. So what we're trying to do is find interior angles of any polygon and its equation when we add them all up. Let's take a look at a polygon. Let's pick a polygon with n sides. That means any type of number of sides. In this case, there are really 9 sides, and n is 9. But let's say we have unlimited amount of sides. Now, remember what we're trying to do. We're trying to find out all the sum of the interior angles of this polygon. That's what we're trying to find out. To do this, what we're going to do is we're going to divide this polygon by the vertices, and the C's represent the vertices, into triangles. And let's imagine all these triangles are pretty much the same. So how many triangles would you form if you had n-sided polygon? Well, you would have n triangles, n number of triangles. So far so good. Remember, we're still trying to find out these angles. Now each triangle has 180 degrees. So if you would want to measure all the possible angles, not just the blue but also the red, we would have to multiply 180 by the amount of triangles we have, and that means it's n. So this 180 degrees, n, includes not only the interior angles, which is the blue, but also the central angle, which is, in this case, circled red. But you see, we're not really interested in the red angle. We're really interested in the interior angles, just the blue. So how do we get rid of this interior angle from our shapes? Well, we do it by subtracting the value of this interior angle, of this central angle, which is 360 degrees, because all the way around is 360 degrees. Right now, when you look at it, wait a second, this doesn't look like the answer we're looking for. We're going to make it look the same. How we're going to make it is we're going to factor. And how we're going to factor? We're going to factor out by dividing by 180. The greatest common factor out of 180 and 360. This means that 180 as a factor has to be outside the bracket, and then inside the bracket we have to do division. 180 divided by 180 is 1. We have only n remaining. And 360 divided by 180 is 2. We have 2 remaining. And voila! Here is what we're looking for. The sum equation for interior angle to any polygon, which is convex. Let's take a look at our next example. In this example, outdoor furniture and structures like gazebos sometimes use a regular hexagon in their building plans. Determine the measure of each interior angle of a regular hexagon. Well, let's define what a hexagon. A hexagon is a 6-figure polygon. And it says a regular polygon, a regular hexagon means that all sides are the same. All same sides. And it's probably a good idea for us to draw this hexagon. And here we go. Here are 6 sided figure, or hexagon with all the sides that are equivalent. That's why they have little ticks through the lines. So the next thing we have to do is we have to find the sum of all the interior angles, because that's what we know. That's what we found out earlier. So this is the sum equation, 180 times n minus 2. Therefore the sum, we just plug in how many, n is refers to how many sides we have, which is 6. Therefore it's 180 times 4, and 180 times 4 is 720 degrees in total. Remember, this is total. The question is asking for each interior angle. Since there are 6 and all the sides are the same, therefore all the angles have to be identical. All the angles have to be identical. So since all the angles are identical, and there are 6 of them, we'll just divide 720 by 6, and we'll get 120 for each angle. And this is the answer we're looking for. Let's take a look at our next example. A floor tiler designs custom floors using tiles in the shape of regular polygons. Can the tiler use congruent regular octagons, so octagons are 8 figures, and congruent squares, that means it's 4-sided, to tile floor if they have the same side length? So they have all the same side length. Now this is really difficult to imagine and see. You probably have to read the question a couple times. But here's the picture that's going to help us understand and help us find out if the squares and octagons can be tiled together. So here they are. Notice that the octagon side and the square side, they have to be matched up and be the same length. Now, how do we prove that they can be all matched up together? We could prove this by choosing one of the corners and finding out that, so let's say you choose this part and this part, that find out that all the way around here, which makes a circle, is 360 degrees. That's the way we could prove this occurring, because if it's more than 360 degrees, therefore there's going to be overlap and one of the tiles will be on top of each other. But if there's less than 360 degrees, that means there's a gap and they won't fit well together. There'll be gaps in the floor. So it has to be 360 degrees perfectly. In order to do this, well, we already know a couple things. We know that this right here is a square inside a square, and that makes a 90-degree angle. We already know that's a definition of a square, when all the angles have to be 90 degrees. But we do not know the octagon angles. We don't know the octagon exterior angles. So let's find them out using the sum formula, which is sum is equal to 180 and adds up to all the angles, interior angles, to any convex polygon. So let's plug that in. Now we have 8-sided figure. We're trying to find this angle here. That's what we're trying to do. We subtract. We get 180 times 6. So we get 1080. Now this is the sum for all the interior angles in an octagon, but we're looking only for one of them. So we're going to divide this value by 8 because there's 8 angles. And the answer is 135. That means this angle is 135. 135. Also, the angle on the other octagon above is also 135. So remember, looking for the number of 360. They have to add up these 3 angles, 135, 135, and 90, to add up to 360 if it were to work. So 130 plus 135 plus 135 plus 90 is 360. Voila! That means we have shown that if we lay these shapes together, we'll get 360 degrees. Now this will work for all the corners, not just this one. Let's move to the next example. ABCDE is a regular pentagon. That means it's 5-sided and all the sides are equivalent. That's what the little ticks are. Determine the measure of angle ACE. So I'm going to show you where ACE is. It's right there. That's what we're looking for. And what type of triangle is triangle ACE? Question. And we're going to explain why. So we're looking for this angle first, the ACE angle. Right now, there's not a single angle in this pentagon whatsoever. We don't know what these angles are. But one thing we can find is the measure of this angle, this angle, this angle, this angle, this angle, because all these angles are the same because it's a regular pentagon. They're called interior angles in a convex polygon. And how do we find it? We're going to use the sum formula. The sum formula tells us that it's 180 times n minus 2, and since we're using a pentagon, n is 5. Plug into your formula, it's 180, 5 minus 2 is 3, so 3 times 180 is 540 degrees. Now this is the sum of all the interior angles. Remember, we still have to take 540 and divide it by how many angles there are, and each angle is going to be 108 degrees. So this means that this is 108, and so is this one. All the interior angles are 108 degrees. Also, this tells me that this huge angle right here is also 108. But it doesn't really help me to solve the question right now. And we're going to go back to it in a moment. So we're just going to erase this one to help us understand. Now, take a look on the right side and left side of this green triangle. There are other triangles, and I'm just going to do it in orange. There's one triangle and another triangle. And notice these two triangles are identical. They have the same sides and they have the same angle. This is called an isosceles triangle. Why is it isosceles triangle? Because it has two sides that are the same. Right? It's equal. And since it has two sides that are the same, they has to have two angles that are the same. Which angles? Specifically the ones that are looking at, that are opposite to the sides that are equal. So these are the two angles that are equivalent. Another thing to note is that a triangle has a sum of 180 degrees. So if we subtract 180 and 108 and divide by 2, we would find the measure of one of these angles. And one of these angles is exactly 36 degrees. So this angle right here is 36 degrees. So is this one 36 degrees. And also on the other side, this is also 36 degrees, and so is this one, 36 degrees. Make sense? Last thing for solving for ACE, the green angle, is that we know that this entire angle right here is the interior angle to this regular pentagon. And we already know that value. It is 108. And we know that this 108 is composed of 36, another 36, and the unknown value is the angle we're looking for. So let's subtract 108, 36, and 36. We'll also get 36. So this means, coincidentally actually, that the missing angle is actually 36. That's the missing angle. That is ACE, 36 degrees. So we answered part A. What about part B? What type of triangle is ACE? Well, we have to know about the sides or the angles of the triangle. So let's take a look at ACE again, ACE. We know that this side is 36, this angle. We just found that out. We know that this is 36. We know that this is 36. We also know that this entire angle, so this is 36, this is 36, this is 36. We know that this entire angle right there is 108. So we could find this angle right there. Oh, by the way, it's also going to be the same as this angle right here, 108. So that means that if we subtract 108 from 36, we will get 72. Therefore, this angle is 72, and this angle is 72 as well. And if a triangle has two equal angles, it has to be isosceles. So we can say that triangle ACE is isosceles because it has two equal angles.